completely, if it says factor completely, that's a red flag that you're probably going to have to factor more than one time. So remember, the steps to factoring are GCF, then DOPS, then trinomial. I'm looking at this. There are no common factors between 16 and 81. I can square root each of these. So my difference of two perfect squares, I'm going to square root that chunk. One's a plus, one's a minus, where x squared minus square root of 81 is 9. Now this is a difference of two perfect squares. That first one is not, because it's not a difference, it's a plus. So I'm going to keep factoring this by square rooting each of those. That is 2x minus 3 and 2x plus 3. Those don't factor again. That is the polynomial factored completely. Sarah graphed the polynomial and stated all roots of y equals 16x to the fourth minus 8 are real. Is Sarah correct? Explain your reasoning. So in order to do the roots are when the polynomial equals 0, and we already know that this polynomial factors like this. So is Sarah correct in saying that they are real? Well, the opposite of real is imaginary, so if they're not real, then they must be imaginary. Setting it up like this, we can see that we would have to say 2x plus 3 equals 0, so 2x equals negative 3, and x equals negative 3 over 2. In this case, we would have x equals positive 3 over 2. In this case, we would have to subtract 9, so 4x squared equals negative 9, divide by 4, and then we would have to square root. When we take the square root of a negative number, and since we're solving an equation when we're square rooting, we have to use a plus or minus. The square root of 9 over 4 is 3 over 2i, because we have a negative under there. So is Sarah correct? No, she is not correct. It says to explain your reasoning, the factor 4x squared plus 9 will result in imaginary roots. All right, 434, the half-life. Half-life, we have a formula for that, of a radioactive substance is 15 years. Write an equation that can be used to determine the amount. Now it tells us what to use of 200 grams of the substance that remain after T years. So we're using our half-life formula, which is either half or 0.5, where we have T over the half-life. Now they tell us to specifically use S of T. P is the initial amount, so they tell us that that is 200 grams. You can either say 1/2 or you can call that 0.5. And what does it say? Our half-life is 15 years, so it's just T over 15. Second part, determine algebraically. That means we can't do it graphically. We actually have to solve it to the nearest year. So we want to make sure we round it right at the end. How long it'll take for 1/10 of the substance to remain. If we start off with 200 grams, we want to know what 1/10 of 200 is. We want to know when we'll have 20 grams left over. I'll start by plugging in 20 into my final amount. Starting with 200, we're solving for T. Now, in order to solve for T, you have to isolate the base first. Don't start with logs. We have to divide out by that 200. And watch what happens here. 20 divided by 200 is 1/10. That 1/10 shows up again. Now we're going to use logs because we're solving for a variable in the exponent. I'm going to use the common log. I'll use the natural log, the ln, if I had a base e. I don't. I have a base of 1/2. I took the log of both sides so that will come out front. The exponent comes out front. This I'm just rewriting. I'll have t over 15 times log of 1/2. Again, I'm solving for t, so I'm going to divide by log of 1/2. Divide by log of 1/2. And I'll pull up my calculator. And let's see, log of 1/10. Close out the parentheses, divided by log of 1/2. And I get this number. You can try math enter. I don't think it works. No. Now, you don't want to round it at this point because it's not your final answer. Don't round any numbers until your very final answer. To solve at this point, what you want to do is just cross multiply. Or you can think about it as multiplying both sides by 15. So you get this 49.8289. Okay, so now we go back up and we reread stuff that we highlighted. Determine algebraically, check, did it to the nearest year. Okay, so it's 49 point something. So 5 or above, give it a shove. My answer is going to be 50 years. How long it'll take for 1/10 of the substance to remain. So now we want to check to see if our answer is reasonable. If the half-life is 15 years, so half of it is going to be after 15 years. So let's just do a quick, is it reasonable? So half of it is going to be 100. That will be after 15 years. Let's do another half-life. That's going to be after 30 years. Let's do another half-life. That's after another 15 years. Now, we said it's going to be 50 years until 20 is left over. So that tracks that it would be about, less than, more than 25 here, less than 25, I mean. If we do another half-life, that will be at 60 years. So it should make sense that 20 milligrams of, is it milligrams? 20 grams of the substance is going to be in between 45 and 60 years. This is just a mental check to make sure my answer is reasonable. Determine the equation of the parabola. Okay, so this is using the other formula, the focus directrix formula. Determine the equation of the focus directrix. So it has this graph here. You don't have to use the graph, but it could be helpful if you're not very neat. It might be helpful to write that on there, and I'm going to use it. Okay, so we have determined an equation for the parabola with focus at 4, -1, and directrix at y equals -5. So I'll just draw a XY axis. Now this is just for my own eyes here. My focus is at 1, 2, 3, 4, -1. This is my focus. And my directrix is at y equals -5. 1, 2, -3, 4, 5. My directrix is at y equals -5. And what we know is that the vertex is in the middle of the focus and the directrix. So my vertex has to be in the middle. If you use the grid that they give you, it's easier to count. So it has to be in the middle. So there's 4 spots in here, so it's 2 away. That is my vertex. And my vertex is going to be 4, -3. Now what you're going to do is plug that into the formula. Now, your formula, you do have to memorize this formula. It's y equals plus or minus, it's happy or sad, 1 over 4f or 4p, whatever you call that, x minus h squared plus k. hk is the vertex of your parabola. I call it f, you call it p or some other letter. That is the distance from the vertex to either the focus or directrix. In either case, because it's equidistant, it's just going to be 2. It's that distance right there that I'm doing in that rainbow color. So that is going to be 2. Now, when I drew that parabola, it was a happy parabola, so I'm going to make sure I put a plus sign. That distance was 2. And my vertex is 4 squared minus 3. And I just have to simplify that a little bit. So I'm going to say 1 over 8 x minus 4 squared minus 3. What I did notice throughout the year is that if you got close to this formula, some of you would forget to put the squared here to make sure that this is the formula that creates that parabola and we get the full 4 points here. It might be a good idea to type it into the calculator and make sure it's what we thought it should be. So 1/8 x minus 4 squared minus 3. And I'll change my window. I'll just change my x max to, remember, an easy way to scale up is just to double things. And that seems reasonable. At least it's a parabola and it's facing the right direction. Okay. Next, we're going to go on to number 36. Juan and Felipe practice at the driving range before playing golf. I had a cat named Felipe. The number of wins and corresponding practice times for each player are shown in the table below. Given that the practice time was long, determine the exact probability that Felipe wins the next match. Okay, so some things. Determine the exact probability. That means don't round it. Probably leave as a fraction. Now it says, given that the practice time was long. There we go. Determine the exact probability that Philippe wins. Okay, so we want to find the probability that Philippe wins given it was a long practice. They just said the given word first. That formula for given is the probability of F given L is F and L over L. All right, so let's look at our chart here. F and L, Philippe and long practice. Philippe and long practice is 12. Let's see, long practice time. We don't have the total, but we have to add it up. Always check to see if this reduces. So I'm going to type in 12 over 27. It does. That reduces to 4 over 9. Now, if you type into your calculator, it's going to be 0.4. Repeat. That's where the exact probability comes in. Don't round it. Don't put 0.4 or 0.44. Leave it as 4/9. Now we want to know whether or not the two events, Philippe wins and long practice time, are independent. Justify your answer. Here we need our test for dependence. there's two ways to test for dependence. Most people like probability of F and L equals the probability of F times the probability of L. And the interpretation is if those two values are identical, then they are independent. If those two probabilities are different from each other, then the probabilities are dependent. So let's determine whether they are independent. The probability of F and L. Okay, so we already know that the number Philippe and long practice, we know that that is 12. But we have to figure out the total. So if we add long practice times, that's 27. Short practice times is 18. So if we total that up, that's going to be 45. Well, let's add it the other way. Juan wins 8 plus 15 is 23, and Felipe wins is 10 plus 12 is 22. That's also 45. So our total probability is 12 over 45. The probability that Felipe is gonna win total, I just added that up. That's 22 over 45. The probability it's going to be a long practice time, I added that up. That's 27 over 45. So type in the left-hand side is 4 over 15, or it's 0.266 repeat. Doesn't really matter what that number is. This one is this number, or it's 0.293, and those are not equal to each other. Since they are not equal, they are different, they are dependent. They want to know, are they independent? The answer is no, they are dependent. Or you can say, no, they are not independent. Both mean the same thing, independent. That's why I was missing the N. There we go. The other way to test for independence would be to use the given formula. I'll come over off to the side. That's a test for dependence that most of you will use. The other test for dependence is, does that equal the probability of Felipe winning? Which would mean that L doesn't matter. So if that's true, we already know that probability of Felipe given long practice, that is 4 over 9. The probability that Felipe is going to win is 22 over 45. And if you reduce that 22 over 5, that equals 0.48 repeat, whereas 4 over 9 is 0.4 repeat. So they are not equal to each other. So for the same reason, they are different. Let's go on to number 37. Okay, so we have Griffin is riding his bike. Now this question is worth 6 points. This is the big one. Griffin is riding his bike down the street in Churchville, New York at a constant speed when a nail gets caught in one of his tires. The height of the nail above the ground in inches can be represented by the trigonometric function f of t, where t represents the time in seconds since the nail first became caught in the tire. Determine the period. Okay, so we have this function. We have to determine the period of the function. Let's recall the formula for period, which is 2 pi over the frequency, which is b. Labeling here, a is at negative 13. B is the number touching the variable, that whole chunk. see is the midline or the vertical shift. So in this case, the period is 2 pi divided by 0.8 pi. If you're going to type this all into your calculator at the same time, at once, try this. You need to put parentheses around that whole denominator or else your calculator is not going to give you the right answer. Try that on your calculator. If you're doing it mentally, you can see that the pi's cancel out, and you just have to make sure that your calculator tells you the same thing. So the period is 2.5. Interpret what the period means in the context, in this context. Okay, so if you're riding a bike, I don't know, there's a seat, and a nail, do a red nail, and right here, you roll over a nail. The bike is still going to be going. So as you're riding your bike, this is going to be going around and around. So the height is going to be going up, it's going to reach its max and then come back down again. Think about the unit circle. One period of a graph is one trip around the unit circle where it'll rise and then it gets lower and then it comes back up again. So what does that 2.5 represent? Well, that 2.5 means that it takes 2.5 seconds for the nail in the tire to make one complete revolution. So it takes 2.5 seconds for this nail to go all the way around. Context of the problem is it takes 2.5 seconds for the nail in the tire to make one complete revolution. Or it would take 2.5 seconds for the tire to go around once. All right, so now we have to graph that. Continue on the next page. We're still going. Now we have to graph at least one cycle. Don't graph 2 cycles, just graph one. Of f of t that includes the y-intercept of the function. Okay, let me go back and write the equation here. Do this over here. So the equation was f of t negative 13, and of course it has a negative amplitude, 0.8 pi t plus 13. Now graphing this on your calculator and coming up with the table of points, that is not going to be helpful in this case. We don't want to do that. What we're going to do is use all the rules that we did when we graphed trig functions. We're going to name each thing on here and help us come up with the graph. All right, so first thing we want to notice is that the amplitude here, my A value, it's going to be 13. But since it's a negative A value, that means it's going to be an upside down cosine curve. So let me start here and say, instead of the regular cosine curve, which starts up here, comes down and comes back, instead of that, it is going to go down first. It's going to start down here, then come up, and then come down here. And that should make sense. You pick up the nail at the bottom, goes all the way around the tire, and then it hits back at the bottom again. We're going to graph that. Now, let's see. I know that this is at negative 13. So it's going to be 13 below the midline. Here's my midline. My midline is shifted up at 13. So what is my max and my min going to be? My y max and my y min are related to the amplitude and that midline shift. it should make sense that your y min is going to be on the ground. So negative 13 plus the midline, that puts me at 0. That should make sense. Your y max is going to be positive 13 plus 13. Your y max is going to be at 26. And I know my midline is at y equals 13, which is the horizontal line. Okay, so I know that this up here is at 26. I know this down here is at 0. Now, what I found out on that previous part was this green, my end point. The period of the graph was at 2.5. That means I'm ending at 2.5. In order to scale my graph, I'm going to take the period and divide it by 4. And that's what each line segment is going, or each box is going to be. So if I do 2.5 divided by 4, that's what each box is. Now, what's nice is it doesn't tell me how far to label it. So since that's a little ugly, maybe I'll kind of ignore that and just put down 2.5 for my ending. So when I graph this, all right, so I have to set up my X and Y axis here. X axis down here. You should use a straight edge, but I can't use a straight edge on the iPad. Okay, one cycle. I'm going to have my X axis. My period is 2.5. So to make it nice, I'm going to make 2.5 here. Really, we want to break it up into 4 equal parts because remember where all this comes from is from the unit circle. So that's 4 parts. I'm going to label that as 2.5. It said at least one cycle, including the y-intercept. Well, here's my y-axis. Here's my x-axis. Now I have to go up to 26. So let's see how we can count here. There are, usually the graphs are 20 by 20 boxes. 8, 9, 10. And they're 20 by 20. So I can't count by ones. So what I'm going to do, let me see. I can count, and I can make every 2 boxes, 3, 6. I can make each line count as 1.5. That's easy enough to count by. Because then I get y equals 12, 15, 18. Okay, then I can fit it all. So now I'm going to start by graphing my midline, which was at y equals 13. So if that's 12 and it's 1.5, y equals 13 is approximately right here. And whatever you graph, make sure you label. And I know that my y-intercept is at 0, 0. My next point is going to be on the midline. My next point is going to be 13 above my midline. So that's going to be at 26, which is right here. Just make sure your points are consistent with your scale. What I mean by that is this line right here is at 25.5, and I have to be at 26. So I went up a little bit higher than that. My next line, again, is back on my midline, and my next point is down at my minimum. So we're going to make a smooth curve. Oh, I missed it. Since I missed it, I'm just going to redraw it. Be a smooth curve, not pointy. And that is 1 cycle. I don't need to do any more than that. You can label this f of t. Now, does the height of the nail ever reach 30 inches above the ground? No, it doesn't. How do I know that? Because I know that the maximum height of the nail is 26 inches. Now it says to justify your answer. So you can, if you wanted to, you can draw the graph of y equals 30. And you can call that y equals 30. That justifies, you can say the graph never touches that line. All right, that's it for this exam.